Right, so to be successful in this topic, it is absolutely crucial that you're able to name, or really it should be label, triangles properly. Now, this might seem like a completely trivial thing, but it's really, really important to label triangles properly. Now, what I mean by that is if you look at this triangle that we've drawn in front of us, I want us to make a sketch of this in a second. But if we look at this just now, you can see that at the corners, at the vertexes where the angles would be, we have capital letters. And if you are standing at those angles and those corners and you go to the opposite side, you will see the same letter but in lowercase. So if we're standing at angle A and we go across the triangle, we get to side A. If we're standing at angle capital B, we go across the triangle and we get to side B. If we stand at angle C and we go across the triangle, we get to side C. So it is absolutely crucial that you are able to kind of follow that and you're able to label the triangle in the correct way. So please copy down that triangle right now. So you've got capital A, capital B, capital C in the corners. Capitals are always where the angles are, and then lowercase letters are always for side lengths. And it's really, really important that you stick to that. So the opposite from the angle is the side length in each one. So if you like, you've kind of got a pair. You've got an angle and a side that are kind of a pair. Got a pair of A's, pair of B, pair of C's. Okay, so copy that in, and then we will look at area of a triangle. Okay, now as it says there, just in that paragraph underneath the triangle, we don't always use letters A, B and C. Sometimes the question will be given to you as any other letter, but what we are going to do is we are always going to relabel our triangles A, B and C, no matter what letters are there, no matter what the information is. Because the formulas that we're going to learn over the next couple of weeks are always given as A, B and C rather than any other letters. Okay, so what we're always going to do is label our triangles A, B and C, and that'll make more sense when we get on to some examples. Okay, so if you've drawn that triangle out, we're going to start to look at area of a triangle. So put a little kind of subheading, which is area of a triangle. Okay, so up until now, area of a triangle formula has been a half times base times height. However, sometimes we don't know what the height is. If you look at this first triangle on the right hand side, A, B and C, well, to get the area of that, I would need to know the height, basically the distance from the kind of horizontal AC side up to B. But what if I don't know that distance? What if I only know the length of the sides? Well, that's when we use this new formula, which you're going to copy down in a little grey box just now. So the area of a triangle, and note that this formula is given to us in a formula sheet, so you don't have to remember it. Area of a triangle is a half times side A times side B times the sine of angle C. Okay, I want you to make very clear that C is a capital, so that is an angle, and A and B are sides. Okay, it says that underneath. So where A, B and C are the sides, so small letters are the sides, and capital A, capital B, capital C are the opposite angles. So the formula is half times side A times side B times the sine of angle C. Okay? So if once you've drawn that formula, okay, I want you to draw this little triangle on the right hand side. So we have at the corners labelled angle A, angle B, angle C. Capital letters are at corners, that's angles. And what we're going to do now is write our corresponding kind of sides. So if you stand at angle A and you go across the triangle, that becomes small a over there. If you are standing at angle B and you go across, that bottom one is side B. And if you're standing at angle C, you go across, that is small letter C. Okay, So the three bits of information in our in our formula are side A, which is that, side B, which is that, and then the angle at C, which is the angle in this corner. So the three things we need always need to be kind of in a little corner together. You need the angle and you need to know the side length either side of it. Okay, so no matter what our triangles are labelled as, what we need to do is we need to use the angle and we need to have a side, we need to know the sides either side of that in order to be able to use this formula. Okay, so hopefully it'll make more sense when we actually do some examples just now. So example 1, A and B, let's just get these done just now. So what I need you to do is draw the first triangle, which is an equilateral triangle. So this is example 1A, and we're asked to find the area. So, draw me that triangle. Now, honestly, this is slightly harder already than the questions you're going to do in a second, because you'll usually be, what we're going to do for starters is you'll be given the side lengths and you'll be given the angles and you just put it into the formula, okay? But we need to kind of know what's going on with this triangle. Equilateral, that word equilateral means all the sides are the same, which means all the angles are exactly the same. If the three angles are the same in an equilateral triangle, that means each one is 60. So can you please mark on 60 degrees, 60 degrees, 60 degrees. It says that each side length is 4 centimetres. So 4 centimetres for each side length, please. Let's mark that on. Now, what we have to do, first of all, and to be honest, in our questions, this information will already be there, but we had to just mark that on there. What we're going to have to do is we have to now label this properly. So you can, in this case, you can start anywhere. Let's start, kind of keep with the same thing and go bottom left is going to be capital A, which means that the opposite side is small a. The top corner is going to be capital B, which means the smaller side down here is small b. Bottom right, capital C, means that side across from it is small c. Okay, now we're going to actually use our formula, and you will need a calculator for this, so make sure you have a calculator handy, please. So write the formula as a half times AB times the sine of the angle C. Make it very obvious that that is a capital C, so you don't put the wrong thing in. Okay, so let's put in the values now. So it's a half times side A, which is 4 centimetres. So half times 4 times side B, which is also 4, times the sine of angle C. The angle at C is 60 degrees. So actually all we have to do, 5th year, is put that whole thing into our calculators now. Okay, so if you can put that into your calculator properly, that's all you have to do. You've got your answer. So get your calculator, and it's a half, or it might be easier to put that in as 0.5 rather than using like a fraction button. That's what I would do. So put it in as 0.5 times 4 times 4 times the sine of 60. Making sure that if you're using a scientific calculator on like Google or whatever, make sure that it is in degrees. So there should be up the top left, there should be a wee button that says either degrees, DEG or RAD. It needs to be in the DEG, or else it's going to give you a wrong answer. Okay, my calculator gives me a third as my answer, but I want to change that to a decimal. So the area, it was giving me 4 root 3, which I changed to a decimal, and it gave me 6.928. That's gone on for a while. Let's just round that to 3 significant figures, so it's going to be 6.93 centimetres squared. That's to 3 significant figures. Okay, so half AB sine C, A and B are the sides, C is the angle in between them. Okay, Let's try another one. Draw that second triangle in example B, please. It's already labelled for us. So let's do it in this. It's labelled, but we'll see if we have to change anything. I don't really like these example notes, actually. The ones you're going to do in the textbook are actually a lot easier. Okay, so we've got a triangle here. We know two of the angles, 43 degrees and 70 degrees. We know two of the sides, 7.2 and 4.6. Now, we said from that picture that we have to have the angle that is in between two known sides in order to use this. Now, regardless of what these are labelled, I'm actually going to scribble them out, and I don't want you to write the labels because we need to change them. So if you've written those labels, just scribble them out. Okay, so what we have to do to be able to use this rule is have the angle in between two side lines. Now, my two side lines that I know are here, the 7.2 and the 4.6, which means I need to find this angle in between them in order to use this area rule. Now, I'm not given that angle, but this is a triangle. The three angles in a triangle add up to 180 degrees. So I should be able to take the other two away from 180 degrees, and then that will be that missing angle. So I'm going to actually ask you to do that just now. Find me what that star angle is. Right? Take the other two away from 180 degrees and write your answer in the comments when you've got it, please. So go, do that now. 180, take away the other two, tell me what the angle is. (180) minus 70 minus 43. You're all telling me 67, so I'm guessing that's right. That's correct. Okay, so that missing angle is 67 degrees. So what I'm going to do is in my diagram, I'm just going to mark that angle in there as 67 degrees. Okay, so now I'm in the position where I have the angle in between two side lines. So now I need to actually, before I use the formula, I need to actually label this properly. So if you look back at your formula, the angle in the middle is always the capital C. So we're going to actually start by calling that top angle C, which means across from it is small c. And A and B can really be whatever you want. Let's go stick with bottom left to be capital A, which means 4.6 is small a. Bottom right is capital.
Sir,
What's up?
see on the notes, like the printed ones, it says that B is the top one.
Yeah, I've scribbled. Are you looking at my screen? Because I've changed it. Okay, so I said we had to change it. I know they started off with the notes labelled differently, but we've had to change it to match our formula. Okay, so don't worry what it's labelled with at the start, because often you're going to have to change it. Okay, so yeah, we've changed it so that C is at the top, because that's the angle we need in between the two side lines, A and B. So now we have everything we need to just put it into the formula. So that's kind of the hard work over. The rest is just putting it into your calculator. So area equals a half times side A is 4.6, side B is 7.2, times the sine of the angle C, which is 67. Okay, I should have started by writing out the formula, but I never. So, calculator, go, give me the answer. Okay, so you're typing that into a calculator, then give me the answer, please. Write it in the comments. Okay, I've got one answer. Nobody else able to get an answer? Come on. Doesn't need. Don't worry about rounding it. I just want the answer that's coming out of your calculator, please. Yeah, so you're all giving me like 15.243. That should be what comes out your calculator. That's correct. So it's 15. So I don't know if a few of you were just hesitant there because you didn't know what you were doing with rounding, but that is correct. It comes out as 15.243, etc., etc., which would be fine to just leave it as that, but we want to try and keep things kind of tidy, so we're going to round to three significant figures. So 1, 2, so it'll be the 2 that we round, that's the third significant figure. So yeah, 15.2 meters squared, and that is to three significant figures. Alright, so actually, to be honest, the two of these questions are actually kind of harder than the ones you're going to do for me for the rest of the period. So I'm actually going to jump to those quickly, and I'm going to try and share my screen and see if you can see the questions.